All right, continuing on with our theme, we're going to look at the same thing. Again, coefficients on our variables, coefficients on our I term. Start off with our Punnett square. I'm going to shift that over just a little bit so I get more space. 4x minus 6i, 2x minus 11i. 2 times 4 is 8. X times x will give us the same base. Add the exponents. 1 plus 1 is 2. 2 times negative 6 is negative 12. Ix. Negative 11 times 4 is negative 44. Ix. And then negative 11 times negative 6 is going to be positive 66. I times I gives us I squared. Same thing as we've been dealing with. Like terms. So I get 8x squared minus 56 I times x plus 66 times I squared. Of course, we know again, I squared is equal to negative 1. We're going to substitute that in. 8x squared minus 56 I to the power of x plus 66 times negative 1. It's going to give us 8x squared minus 56 I to the power, or ix, not I to the power of x, is 56 times ix minus 66. And again, I don't see any like terms here, so I've reached my answer. Getting closer to being done. Now, this is a case of what we're going to call conjugates. And what makes these conjugates is you have x here, the same last term, 2i, but you have opposite signs. Okay? That's what makes this conjugates. And we're going to see what happens in this special case. Some of you might already be able to predict it. We'll start off by creating our boxes. X plus 2i on the top, x minus 2i on the bottom. Our exponents on x are both 1, so 1 plus 1 is 2, so we get x squared. X times 2i is 2ix. Negative 2i times x is negative 2ix. And I times negative 2 times positive 2 is negative 4. I times I is I squared. As we've seen, we're going to have like terms on our diagonals. But what's going to happen this time is that I'm going to get x squared plus 2ix minus 2ix minus 4 times I squared. And what we're going to see here is that these terms here are going to cancel each other out. And so your middle term in conjugates will be canceling each other out, leaving us only with x squared minus 4 times negative 1. Which means this is going to be equal to x squared plus 4. So the conjugates of x plus 2i times x minus 2i will multiply together to give us x squared plus 4. And this kind of makes sense because we know this only returns imaginary zeros. So it stands to reason that if I were to take the conjugates of two imaginary binomials and multiply them together, I would end up with a quadratic, or a second degree polynomial, that doesn't give us real zeros, but rather returns imaginary zeros. Finally, in this case, we're going to see our old pattern of squaring binomials. Again, the first thing to remember here is that that is actually x minus 5i times x minus 5i. So we draw our Punnett square for it. And I get x, 5i, plus 5i, x plus 5i, I get the exponents are 1, so I get x squared. X times 5i is 5ix. 5i times x is 5ix. And then 5 times 5 is 25. I times I is I squared. And that's what I'm going to get here. I then go ahead and add everything together, including my like terms again on the diagonals. And I end with x squared plus 10x, or plus 10ix, I should say, plus 10ix plus 25i squared. I remember that I squared is equal to negative 1. Replace that there, and I have x squared plus 10ix minus 25. There's nothing else I can combine together there. Those are all in like terms, and so that would be my answer. All right, that's today's lesson. Hopefully it wasn't too boring. We'll probably go over a little bit on Monday as well, but do anticipate a quiz on Monday over this stuff as I've talked to you about. Please watch this video, and if you've watched this all the way through to the end, please go ahead and send me a message on Canvas saying video watch.